Hey guys, in the last video we talked about 4.2. In there we learned about a compound interest formula and also the present value. So pretty much for 4.2 they are all like formulas for us to plug in numbers, and the meaning behind those formulas is that say if you invest like an amount of money into a business after an amount of time, those formula will tell you how much you're gonna get after those time that you invest your money in. Okay, so for example, if you invest say like $100 into like Google company, after 5 years they like the profit, the interest is gonna give you will be somewhat around like, I don't know, like 5,000 or something like that, because as you can see Google makes a lot of money and it's a big company. It develops like every year, right? Like every minute, every second of the day. So that's a good investment. Okay, as a business major, those formulas are really important, but then if you don't want to memorize them, that's fine too. Like if you are like working for a company or something like that, I'm pretty sure the computers will have those programs when you don't have to memorize those like formulas. You can just plug in the data and then there you go. They'll tell you the profit or like the interest that you make after an amount of year. Okay, and that's about 4.2. For 4.4, let's talk about logarithmic functions. Alright, so the last time we talked about one-to-one functions. It's not covered in 4.2, but I believe we talked about it in 4.1. So one-to-one function, what does that mean? Let me remind you guys. One-to-one functions are the functions happens when for one y value we only get exactly one x value. Okay, and it cannot be more than one x value. For example, if I give you something like, I don't know, like a parabola or something like this. Okay, this is not a one-to-one function because, for example, say if I plug in y equals to, okay, first of all let me draw like the xy axis in here. Okay, that's not like a good x-axis that I want to. Okay, there we go. So y-axis, x-axis, and this is the basic parabola x squared, y equals to x squared in here. If you plug in, I don't know, like x equal to 1 or negative 1, you're gonna get y also equals to 1, right? So that means we have the point of 1 1 right here, and also the point of negative 1 1. Okay, so for one y value of like 1, okay, so in here let me write it down. So for when y equals to 1, you have like two x's, right? Like you have x equal to 1, and you also have the case of x equal to negative 1, right? This is a big no-no for one-to-one function. Okay, for one y value we can only get exactly one x value. Okay, and if you don't want to think about it like that way, remember we also learned about the horizontal line test, right? It tells you that like just imagine if you have like a pink pen or like a pencil and you move it across your curve, across your graph. Right here it doesn't have any contact whatsoever with the graph. Right here it touches the graph once, only once, right here. Alright, but if you move a little bit more, if you go up here, then it touches your graph twice, right? Like one in here and the other one in here. Okay, so it tells you that it passes your graph more than one time, which tells you that this graph failed to be a one-to-one function. It is still a function, right? But it's just not one-to-one. It doesn't have the property of one-to-one. Okay. So for inverses, we can only talk about like one-to-one functions. Okay. If your function is not one-to-one, your function doesn't have an inverse. Okay. So let me take these out of the paper for less confusion. Okay, so just imagine you have a one-to-one function, y equals to f of x. This one, it has an inverse function that is defined implicitly by x equal to f of y. X equal to f of y, yeah. Okay, so let me highlight this one. So remember that your original function, it is y equal to f of x, right? But then later on, when you get the inverse function of that original function, you're gonna get x equal to f of y. Okay, and if you remember, I told you guys the way to find the inverse function of a given function is that we're swapping x and y, right? So if you look at the relationship of the two like functions in here in highlighted orange and red, you can see that we're swapping the places of x and y, right? That's why they are inverses of each other, okay? So in particular, the exponential function y equals to a to the x, where a is greater than 0 and a must not be 1, it's 1 to 1, right? And hence it has an inverse function. So for the inverse function of exponential function, we have two ways to define it. The first way, we define it implicitly by writing y equals to a, x equals to a to the y power. There we go. Okay, let me take out the circle, and let me also highlight this one. So let me put this exponential function. This one is our original function, and x equal to a to the y power. This one is our inverse function, okay? So again, we're swapping the places of x and y because they are inverses of each other, okay? And in here, again, the condition must be the same. A cannot be 1, and a must be a positive number, okay? That's one way to do it. That's one way to write the inverse function of the exponential function. The other way, if we want to do it explicitly, we can write y equals to log of a, log a of x, okay? So there are three ways to say this expression. The shortcut for it, if you want, you can call it log a of x, okay? The second way, if you want, you can call it log base a of x, okay? Why do we have to include the word base? Because if you remember, let's go back on the exponential function. A in here is the base, right? Let me just write a equals to base, and x in here is the exponent. That's why if you want the second way to go for this expression, we can call it log base a of x, okay? And the third way, if you want to be fancy, just like a textbook, you can read it as logarithmic function to the base a of x, okay? So there are three ways to say it, but you know, like in short, I usually call it log a of x, okay? If you want, you can also do it. It's cool with that. Okay, so the condition must be the same again. A has to be positive, a cannot be 0. If you notice, for the exponential function, we have a cannot be 1, but then for the logarithmic function, a cannot be 0, okay? That's like one of the special restriction, like difference in restriction between exponential function and logarithmic function, okay? That's just how we kind of like restrict the domain of it, okay? By restricting like the number of a, okay? So that is defined by this formula right here, the one that we had earlier in the circle, y equals to log a of x, okay? This happens if and only if x equal to a to the y power, right? So I told you there are two ways to represent the inverse function of exponential function. We can have it implicitly like this or explicitly like that, okay? So these must be like equivalent, like have the same meaning to each other, right? So this happens if and only if this happens, okay? And a quick way to remember this is that, first of all, let's focus on this function. Let's write in here y equals to log a of x. Okay, my trick is that, first of all, you have to swap the log and the y. So I'm gonna write a log on the left hand side, and I'm gonna write a y on the right hand side, okay? Notice is that when you write out base a, make sure a in here is like is lower than log, okay? Don't write something like log a x. This is wrong, okay? Don't write something like log a of x. A in here is not like the power, so this is also wrong, okay? So a must be like lower compared to log and to x, okay? So once you have log on the left hand side, here's my trick. Let me put it in pink. Okay, you're gonna do it in a circle manner. What do I mean by that? You're gonna start with a to the y power, and you end up having it equals to x. So let me write down. So I have a to the y power equals to x, okay? And this y right here, it is the exponent, okay? I'm trying to make it like as small as it can to like make it look like a power, but you got this. It's just like a to the power of y, okay? It's not like ay, okay? So this one in here is not ay, okay? It's a, but then to the little y on top of it, okay? That's what I mean, but then it's hard to write on an iPad, okay? So if you look at this formula in here and compare it to this formula right here, they are the same thing, right? But I'm just swapping the size of the equation. To me, it's easier to remember it in this way because everything is going by the circle. That's like the shortcuts for us to remember how to switch from the log form to the exponential form, okay? And like the symbol says it all, but let me refer it one more time. Let me take out all these marks. Okay, so this one in here in orange highlight, this one is the log form, and this one in here in the red highlight is the exponential form, okay? So it's in the log form, it has the word log in there. Ours is in the exponential form, okay, because it has a power. Like in here, this one, it has the power of y. Okay, so this one, again, exponential form. This one, log form. Okay, and the domain of the logarithmic function y equals to log a of x, it is everything that is greater than 0. So x in here, it cannot be negative, it cannot be 0, okay? It must be a positive number strictly, okay? Next one, from our previous algebra courses, we should be somewhat familiar with logarithms. For instance, the common logarithm, log 10 of x, is defined as, okay, let me highlight this one because it's really important too. Let me use, I don't know, pink. Log 10 of x equal to b. That means that, okay, let me do a circle for you guys for this one again. So we're going to have 10 to the b power equals to x, okay? And that is what I mentioned in here. 10 to the b power equals to x, okay? Those are like another form of each other. They mean the same thing, but it's just like different looking, okay? Just like how you have like 1 and 1 is the same thing as 2, but then they mean the same thing, but they just have like different lookings, okay? So the base of common logarithms is 10, okay? Why is that so? Because if you see on the log in here, the base in here is 10, right? Because it's below the log. Whatever below the log, we call it the base. For example, we have like the a in here. Let me make like a better circle for a. Okay, let me just underline it. Okay, there we go. So whatever number you have underneath of log, like right next to log, we call it the base, okay? Alright, in calculus, the most useful base for logarithms is number e. If you recall this like irrational number is really important in calculus, you can see it in your calculator. It's the e button. It's really important in the sense that we can like get the limit, we can get the concept of derivatives through e. So let's talk about a definition of natural logarithmic functions. It is ln x, or if you want to call it shortly, just call it ln. Okay, let me highlight it here. Okay, it's defined by ln x equals to b, okay? And again, another way to write this one is, let me put it in pink. Okay, this like another way to write ln x equals to b is that we can write log base e of x equals to b, okay? So if you try to make a comparison, let me put it in orange, ln in here equals to log base e, okay? And log in here equals to, okay, let me put it in orange again. No, actually, let me put it in, I don't know, blue. Okay, if you see log x equal to b, it means log base 10 of x equals to b. Okay, and orange. So just remember one thing. Log in here, it means base 10, and ln in here, it means base e. Okay, let me take out this circle in here. Okay, so make sure you can tell the difference in here, and make sure you can tell the basis of each log. Okay. These two logs that I put in pink and in blue are the only two that stand out from the most of the logs in here. So we have like the common logarithmic, which is the one in blue. Let me highlight it in blue also so that you guys can know the name of it. Okay, and the other one, let me highlight it in pink. This is called the natural logarithmic function. We can refer to it as ln. Okay, those are like the two that stand out the most out of logs. They are also important. They can have like different bases, but we don't have like any names for them, okay? In general, they're just like logs, okay? And this happens if and only if e to the b equals to x. So let me put, I don't know, purple. So this in here is a circle thing if you want to think about it in that way in here. So we have e to the b equals to x, okay? So again, if you want to do the circle thing like what I did just now, make sure your log has to stay on the left hand side strictly, okay? If you have your log stays on the right side, for example, something like this, you cannot make it that way. You cannot draw a circle. You cannot do it in a circle manner to put it in the exponential form, okay? Because that's wrong. It's not going to get you anywhere, and most likely it's going to confuse you even further, okay? So let's talk about the first objective of today. Okay, again, you see this table. Again, it just has the same meaning. It's the tool that we use for graphing. If you have the original function or like the parent function, if you don't want to go by the table, that's fine. But I'm just putting it there to give you guys like more options to graph like a function, okay? So I'm not going to talk about this one unless you guys want me to like explain it further. If you want to, you can Google, you can like search it up on Google again. Just type out transformation of function graphs. They will tell you like the meaning of them, like how to do them, or like examples of them. But again, I'm not going to test you like super strictly on this one. I'm not going to even ask you the meaning of this one, because we're in business, right? Like this is like really strong in math, but then I don't think any of you guys will need to graph an equation when it comes to real life, right? Like when you get a job in business, I don't think anyone will ask you to graph something, okay? So I'm gonna skip this page, but if you have any questions, let me know. All right, first objective, the natural logarithmic function. And again, when you see the word natural, make sure you remind yourself of ln, okay? And ln in here, it means that you're gonna have the base e, okay? And e again in here is a irrational number. If you type it in the calculator, e equals to like 2.7 something, okay? I don't remember the whole like all the digits, but you get my you get what I say, okay? E in here is just like a bad number, just like pi. We call it e because that's like, it's very important to like calculus, but on that, that's just that, okay? All right, so note that the natural logarithmic function and the natural exponential function are inverse functions of each other. So every logarithmic equation can be written in an equivalent exponential form, and every exponential equation can be written in logarithmic form. For example, if you have ln1 equal to 0, so in here, if you want to rewrite it in another way so that you can see the base for this in here, let's write as log base e of 1 equal to 0. And again, in here you can do the circle, you can do the swinging thing. So you have e to the 0 equals to 1, which is what I had in here, okay? Let me just take out the circle stuff. Okay, there we go. So again, make sure your log is on the left hand side if you want to use my trick to convert from like log form to exponential form, okay? So that is what we get if we go from log to exponential. Okay, my arrow is pointing at the weird place. Okay, log to exponential. There we go. If you start with the exponential form, how can we get the log of it? Well, okay, it's gonna sound a little bit difficult. It's gonna sound a little bit like hard because we haven't talked about the rules yet. But for now, because you got that, because we know that this in here can be written as this in here. So then first of all, if you have like e to the first power equals to e, we're gonna have something like log e of e equals to 1. Why do I know that? Because in here, if I write like this, and if I do the circle thingy, I'm gonna end up having e to the first power equals to 1, okay? To me, it's more natural to convert from like the log form to the exponential form. Backward is harder. Like after you finish learning this section, or like this section of 4.4, you're gonna get a hang of it. It's easier for us to do. Well, you're gonna have to take like ln of both sides, and what I mean by ln, I mean like ln, okay? So like throughout the videos and throughout like the lectures, if you ever heard me calling it ln, it's just ln, okay? But I don't know, like I just call it ln because everyone does. Okay, so again, it's harder to think about like e to the first power equals to e means that ln equals to 1, but then it's easier to think about the other way around, right? Because this one, again, you can rewrite it as log base e of e equals to 1, the same thing I just had, and then you take the circle, swing it, and then you have the beginning one, okay? I'm not gonna ask you to do something as hard for, well, like super difficult or hard for natural logarithmic functions, because I mean, this is like useful because if you like want to make profit for like a business, you have to learn this one. But then again, you're gonna have like tools, you're gonna have like computers, laptops, and programs to help you with this. So as long as you know the concepts of what you're doing, then you'll be fine, okay? I'm not gonna like be tricky about this one. So let me get rid of this right here. Okay, let's talk about a graph of them. So we learned from the last time that the graph of the exponential function is going to look like this. This is the graph of e to the x, or the exponential function. How can we get this graph? First of all, we go for the y-intercept by plugging 0 in here, e to the 0. Anything to the 0 is 1, okay? And then if you go for another random point, for example, let's plug in like -1 in there, you're going to have like e to the -1, which is 1 over e. If you want to compute it in a decimal form, you can do that. That's the second point right there, okay? And if you connect the 2 points together under a curve, you're gonna get this red curve in here, okay? And because they are inverses of each other, they should be reflected by each other through the line, through the dashed pink line, y equals to x, okay? Let me trace it and let me circle the name of it, okay? And if you reflect it over the y equal to x line, let's put it in blue. This point in here will become 1, 0, okay? Like you flipping the x and y. So at the beginning you have 0, 1. Now, after you flip it, you're gonna get 1, 0, okay? And for this point right here, at the beginning you have -1 and 1 over e. After you've reflected over the line y equals to x, you're gonna have 1 over e and then -1, okay? So what happens from here to here is that we're switching between x and y, okay? And if, again, you want like a third point, which I don't think necessary, but then if you want to, you can also like have the third point, like the pictures, like what the picture does in here. So at the beginning you have like 1 and e. After you flip it, you have e and 1, okay? So now that you have like 2 or 3 points, you can connect them together. And make sure you don't do any lines in here, okay? Because like as you can see, these 3 points cannot make any line, right? So they have to make a curve, okay? So if you connect all the 3 blue points together, you're gonna get this curve, okay? And the function of it, we call it the inverse function. That's why it has like the little symbol of like -1 for inverse. And this one, it is y equals to ln x, or like g of x equal to ln x. Notice that at the beginning, I call it f of g, like the function is named f, but then later on, I cannot use f again because I already used that name, right? So just imagine in a family, you don't want to call your, like, you don't want, okay, so just imagine you have like 2 kids, right? And if you name the first kid, I don't know, like Selena, you cannot, or you don't want to call the second kid also Selena, right? Because when you call like, hey Selena, like they don't know which Selena you're talking about, right? So if you go for f for the first function, you don't want to call the second function f anymore. So you have to change the name for it. That's why they're going for like g. But if you don't want g, you can use another name like h or like ABC or whatever alphabet letter of your favorite, okay? And here is the list of all the property of the inverse function, or the logarithmic or the natural logarithmic function. The domain is like has all the value of x that is greater than 0 strictly. The range in here, it covers everything on the y-axis from -infinity all the way to +infinity. So your y could be bigger than 0, smaller than 0. It could be equal to 0, okay? The intercept in here, so if we have the intercept 0, 1 for the exponential function, and here we're gonna flip them around, okay? So it goes like 1 and 0 for natural log, okay? And it's always increasing, okay? So if you notice, the blue line here from left to right is going up, right? So from the bottom up top, it's going up. So that's why it's always increasing. Okay. The next two lines you don't have to know about it. We're not gonna even like talk about it. I'm not gonna test you on this one unless we learn about the derivatives, but not for this lecture, not for now. Okay. It's continuous in the sense that if you pick up, just imagine it, if like the blue curve in here is a thing, and then you can pick it up, you can pick it up just at just one piece, right? It's not going to drop any part of your blue curve. That's why it's continuous. It doesn't break out any part, okay? And also it's 1-to-1 because it passes the horizontal line test. So just imagine if you have like an orange pencil and you move it like from bottom to the top of the blue function. If you place your pen right here, it has no contact with the blue line, blue curve. If you place your orange pen right here, it touches the blue curve once right here, and at any time, like later when you're moving your orange pen up or down, it only just touches the blue curve only once, right? So that's why it's 1-to-1. Okay? So personal tips. To sketch your graph of logarithmic functions, I always plot the x-intercept. That's like 1 point. And another random point. That's the second point. And identify the VA, the vertical asymptote. Okay, so if you think this one sounds familiar, then yes, we actually did the same procedure, like pretty much the same procedure to sketch the graph of exponential function, but instead of having the x-intercept, we did the y-intercept. Okay, so let me use brow in there. So okay, first of all, let me just circle this. So this is logarithmic function, right? And then let me remind you guys of the exponential function by putting it in purple. So for exponential function, we're gonna sketch, well, first of all, we need 2 points, right? The first point is the y-intercept, and the second point, it can be like any convenient point or random point. And then lastly, we have to go for the horizontal asymptote, and then we connect like the curve, we connect the points together, right? So same deal in here, but then we're gonna have the vertical asymptote, not the horizontal asymptote anymore. So as you guys can imagine, the asymptote or like the dashed line is gonna be vertical this time, okay? And because it's vertical, it's gonna have the form of x equal to something, okay? So horizontal asymptote, it has the form of like y equal to some number. For example, y equals to 1, y equals to -2, y equals to 100, or something like that. For vertical asymptote, it has the form of x equals to a number. For example, you can have x equal to 10, x equal to -100, anything, okay? So let's talk about the first example in here. Sketch a graph of the following functions. So for my example, I have f of x equal to 2 ln x minus 1. So first of all, I'm going to do the x-intercept, right? And to find the x-intercept, first of all, I'm going to let my y equal to 0. So if I let my y equal to 0, what do I get in here? I'm going to get 0 equals to 2, and then ln, and then x minus 1. All right, what do we do here? Well, first of all, we have to isolate the ln, okay? So what I mean by ln is that ln and its belonging, okay? Like you cannot just isolate ln just by the word ln by itself. No, it doesn't work like that, okay? Ln is a function and it's sticking with like something, okay? So in this example, for my example, x minus 1 is the belonging of ln, okay? How do I know that? Because first of all, it stays right behind ln, and they are in the parentheses right after ln, okay? So that's how I know that x minus 1 in here is the belonging of ln. So next up, I want to isolate ln of x minus 1. That's why I'm going to divide both sides by 2. So these two canceled out, and then 0 divided by 2, I got 0 in here. And let me switch the sign of like ln and 0. So next step, I'm gonna get something like that, right? And then I told you the trick is that ln is actually log base e. So then let's put it back like that. And then if you remember my trick with the circle thingy, we're gonna have e to the 0 equals to x minus 1. So let me put it up here. So e to the 0 equals to x minus 1. And if you remember from the last sections, e to the 0 or anything to the 0, anything to the 0 is 1. So we have 1 on the left hand side, and we can just copy the right hand side. Now, if we want to solve for x, we add 1 to both sides. Cancel in here, and we have x equal to 2. Okay? So the very first point that we have in here is 2, 0. Okay? All of that work just to get 1 point, right? So I know it's harder than compared to the last one, because the last one you just have to plug it into the calculator, but this one you have to do more work, right? I mean, it's math, right? So it's always hard. Alright, so let's plot it out. So we have 2 and 0. It is right here. Okay, that's our first point. Okay, now the second part, easier part. So you can plug in any value for x that you want to. First of all, let me just get rid of these, like work, so that I have like more space. Alright, second point, let x equal to, I don't know, 1 maybe. If you put this into the calculator, you're gonna get 2 and then ln and then 1 minus 1. Uh-oh, we have an error, right? Why is that so? Because remember, for one thing, is that the domain of ln, it cannot take 0, right? So if you plug in 1 in here, on the inside of ln, you actually get a 0, right? Because 1 minus 1 is 0, and that's a big no-no, okay? In other words, if it shows you an arrow, just pick on another number. So let's not pick on 1, okay? Let's do x equal to 2, okay? If you plug into the calculator, we're gonna get 2 ln 2 minus 1, and equal sign, we have y equal to 0. And uh-oh, this is the point that we already found, right? So let's not do that. Let's do x equal to, I don't know, 3 maybe. Okay, let's see if we're gonna get something different this time. Alright, so this time we're gonna do 2 ln of 3 minus 1. Okay, great, we have something different this time. We have 1.39 if you round it off, okay? So this is the point 3 comma 1.39, right? So we have 3 on the x-axis, and we go up 1.4. So it's gonna be like right here approximately. Okay, and if you remember the form for it, the ln, it looks like this or that, right? So by the two curves in here, we're gonna get this. But wait, we're missing the vertical asymptote, right? I told you guys there's a vertical asymptote. So what is the vertical asymptote for this one? Let me backtrack a little bit and erase my curve. Okay, so my question is, what is my vertical asymptote? And if you guys remember the last time when in the exponential equations, the way that we figure out the horizontal asymptote is that we look at the free number, right? And what I mean by the free number, I explained it in the last video already. So if you have any question on that, please look back at that video. But technically, like, free number is a number that stays out of function, okay? It cannot be something within your function, okay? So for my example in here, there's no free number. So that means my VA, my vertical asymptote in here, it is x equal to 0, okay? Just like how we did it for exponential equations, but instead of having y, now we're gonna have x. That's the only thing that's different, okay? So y equal to 0, this is actually the y-axis, if you notice. So let me just put like a dash curve, a dash line here for on the y-axis for the vertical asymptote of x equal to 0. And after that, I'm gonna draw my line. Bam, okay. Now, if you forget the vertical asymptote, there are actually a lot of ways to get this one wrong. First of all, some people, they might have the correct form to it, but then they might go across the vertical asymptote, which is wrong, right? Another common mistake that I see a lot of people doing is that they mistake this for the exponential function. So for the 2 points that they have, they draw this curve of exponential function, which is not correct. Okay, so let me do it in orange in here. So remember one thing, for exponential function, it looks like this or it looks like that, okay? This is exponential function. While for logarithmic function or for ln, it looks like this or it looks like that, okay? So make sure you can tell the difference in here, okay? So let me put a green star for your example. This is your part, okay? And let me take out the wrong graph before you mistaken them further, okay? So the red curve in here is the correct function, okay? And again, in the test, make sure you label them, and I'm gonna show you guys how to label them. This point here is 2, 0, so make sure you put 2, 0 in here. This point here, let me first take out these. Okay, so the second point that we had in here is 3 and then 1.39. And this curve in here has a name. It is called f of x or y, doesn't matter. You can write it either way, equals to 2 and then ln of x minus 1. And lastly, for the vertical asymptote, you can just put x to the 0. Okay, so this is how you label them. You have to tell me the 2 points that you use. You have to tell me the vertical asymptotes that you get, and you have to tell me the name of the function, okay? So let me erase some stuff in here so that I can show you guys. For your problem, you actually have a free number, and let me put it in green. The free number in here is -1. So your vertical asymptote, it is x equal to -1, okay? This is just like a heads up, okay? And again, this is your part, okay? And now let's move on to the next objective. Number 2, properties of logarithmic functions, okay? So just like the table of properties for exponential functions, we have some properties also for logarithmics. We have less than 7, not just like 7, just like the last time. We have 5 properties in here. The very first property, if you have ln e to the x power, it equals to x. Why is that so? It has something to do with this one. So first of all, let me tell you about this one first. Okay, let me take out the circles. Okay, so there's, if anything that you have to remember on this page, I would recommend remembering this formula in here, this formula in here, and this formula in here. Okay, the other 2 formulas, they are useful, but I'm gonna tell you how to get to them, okay? So I have no explanation on the 3 formulas in pink. You just have to memorize them. Technically, on this formula right here, what you do is that you take the power and then you bring it in front. That's what you do, and that's it. Okay? Okay, I can do a better circle on the end. There we go. Okay. For this one right here, if you have multiplication, it means addition, and if you have division, it means subtraction. Okay? But this can only go one way. These 2 can only go one way, okay? So say, for example, if you have like ln of like, I don't know, like x plus y, this does not equal to ln of x times y, okay? Addition does not imply multiplication. So this is like a bad one, okay? And again, for this one in here, subtraction doesn't imply division. So for example, if you have like ln of x minus y, and you think that it should be equal to ln of x divided by y, this is wrong, okay? Because subtraction cannot imply division, okay? And if you notice, there's a big difference in here. Let me put it in orange. This one, you have like 1 log in the formula, in the proper formula. You're supposed to have 2 logs, okay? So we're going from multiplication and division to sum to addition and subtraction, but not the other way around, okay? This is one of the questions I'm gonna put in the exam, so make sure you prepare for it and make sure you know the answer for it, okay? Make sure you know that this is not correct if we go like the other way around. If we go from addition and subtraction to multiplication and division, it's wrong, okay? All right. The last 2 formulas that I didn't highlight in pink, let's talk about this one right here. But first of all, let me erase some stuff in here so that we have more space. But make sure you remember the 3 formulas in pink. Okay, so let's talk about this one right here. Okay. Again, because you have an exponent in here, you can bring it out. So it becomes x and then ln of e. But then remember, by definition, ln of e, it is 1, okay? If you don't remember it now, let me put it in another color so that you guys have to like remember that one. This is like the must to remember, okay? Like this is like one of the biggest formula to remember. ln of e equals to 1 and log of 10 equals to 1, okay? Let me box these two, okay? Because they are really important, okay? With this saying, I mean, with the first formula in here, it tells you that ln of e equals to 1. That means in here, we have x times 1, and x times 1 is just x. That's why the right side here is just x, okay? And as for this one, okay, how can I think of this? Okay, a quick way to think about this one is that just imagine if you can swap e and x, then you're gonna get something like e to the ln, I mean x to the ln e, right? We're swapping the positions of x and e in here to get to get x to the ln e, and again ln e in here equals to 1. So then this is equals to x to the first power, which is x. So again on the right side we have x, okay? And you find these two logic have like hard to remember, just write these two formulas down also, just to have it ready for the test, okay? Now let's talk about the example. Part A. So what does the question ask us to do? Expand or condense the following logarithmic expression. Oh, and by the way, before we get into it, there's one thing about like the note that I have been like read it out. Recall from 1.4 that inverse functions have the property that when you plug them into each other, you're gonna get x out of them, okay? So that's just like one of the things that you can recall. So that's also why we have x in here and in here, because ln and e, they are inverses of each other, okay? All right, let's get into the first part of 2. So we have one term minus by the other term, okay? And notice that in here we have more than one logs, right? We have like this one log in here and we have like another log in here. And what do I mean by log? I mean like we have two ln's in here, okay? This is the first ln, this is the second ln. That means in this case we're gonna condense them, we're gonna combine them, okay? And by the way, if you like don't know what condense means in English, it's just like combine them into one log. Okay, so let me kind of like explain a little bit the English term in here. Expand. Okay, let me write in here. Expand, it means you go from one log to more than one logs. I mean to more than one log. Condense, let me just put con. It means you go from a lot of logs, say 2 or 3 logs. It could be more. And then you get to one log, okay? So that's about English, okay? So in here, if you see like 2 logs, it means that you have to put everything under just one log, okay? So let me get these out of the way. All right, so this one in here, first of all, to combine them, you're gonna have to kind of like get just the log and nothing in front of it. So for the first log, we have the 2 in front of it, and because like it's in front of it. Okay, let me actually explain this formula a little bit in here. So the way that we can read the formula in Paint, I just write in here, is that we can read it from left to right, and we can also read it from right to left, right? So say if you have like an n number in front of the log, then you can bring it back as a power for like whatever you have inside that log, okay? So that means that if we have the 2 in front of log in here, that's actually the power of like the things inside the log. Okay, so this one in here, it equals to ln of x minus 1 squared. Squaring is for that too. And for similar like reason, the 1/3 in here, we can bring it back as like the power of the log. So we can go minus 1/3 x, I don't know, minus 1/3. Wait, what am I saying? Minus ln, okay, and then x to the 3rd power plus 2, and then 1/3 power of 1/3, okay? And again, if this doesn't make sense, let me know, okay? And lastly, we're gonna draw them together, so let me get rid of these to get more space for us. All right, last step, we're gonna really combine them because there's nothing in front of the first ln and there's nothing in front of the second ln except for the subtraction side, right? And by subtraction, we're gonna do division, okay? So we have 2 logs on the subtraction. That means we have 1 log on the division or fraction. So whatever goes first in here is the top part. We're gonna write on top. And whatever goes second, that's the second part. X cubed plus 2 all to the 1/3. And that's it. So this is the answer for part A, okay? Again, if you have any questions, let me know. Now, with part B, with a similar logic, the 4 in here will be the power for x minus 3, the 3 in here will be the power for y, and then the 5 in here will be the power for z. And we have subtraction in here, we have addition in here. Okay, so my trick in here is that if you have a minus in front of it, it means that your log, the belonging of the log will go underneath of the fraction, and if you have like an addition in front of your log, that means that the belonging of the log will go on the top. What do I mean by that? Shortcut, I have log in here, and then fraction because I have 1 subtraction in there. The 4 in here, it is actually positive 4, right? And because it's positive, it's going to be on the top part. So we're going to get x minus 3 to the 4th power. Okay, the second term, we get y, and then we get a minus, and then that's a 3, if I'm not wrong. Okay, that's a 3. And because this is a minus, so the y will stay on the bottom, and its power is 3, because the 3 is the number in front of the second term, okay? And for the last term, let me get rid of all that. Okay, the 5 and the z, because 5 in here is positive, that means that z will stay on top. So we got z in here on top. Let me extend the fraction line. And the 5 in here will be the power for z. So we have to the 5th power. And that's all. Okay, let me write a better 4 in here, just in case you guys wonder what it is. Okay, so this one is like x minus 3 to the power 4. And then let me rewrite this one because it looks awkward with y3 not like being centered. Like that, okay? And of course, you cannot do it like this in the assessment because I'm running out of space. I'm just trying to show you guys how to get it in like a shortest way. But in a test, make sure you show like the full version of your work. What I mean by that, I mean you have to show me these work and then the final answer, not just the final answer, okay? And with the similar logic, okay, first of all, let me just get rid of this because I cannot see the problem. Okay, with the similar logic, for part C, let's see, what do I get? First of all, we have the 1/4 in there, right? And we have like parentheses, these parentheses. So what we're gonna do is that we're gonna distribute the 1/4 into the first term and the second term. So 1/4 times 2, we're gonna have 2 over 4, which is 1/2. And then ln of x plus 3. And then after that, we're gonna get 1 over 4 x, and is supposed to be a subtraction in here or like a minus sign here, like that, okay? And again, shortcut, we're gonna bring this number back for the power, this number back for the power. But wait, on the second term, we don't even have any power, right? So what we're gonna do, we're not gonna bring it back anywhere. We're just gonna keep it as negative 1/4 x. And the final answer in here will be ln of x plus 3 to the 1/2 minus x over 4. That's it. We don't have to combine them, right? Because like the second term, it doesn't even have a log to combine with the first log, okay? So just leave them as they are. But as for the final answer, make sure you have nothing in front of your log, okay? And that will be fine for me. And now for D, let's expand it out because we only have like 1 log to start with, okay? I'm not sure what's going on.